Hello, there we go. Okay, cool. We're live. Um, um, I just didn't connect my my mic. It should be working now. Let me just double check something. Okay, good. Getting some feedback. I'll turn that down, and we should be all good. Is my mic still? Yeah, 1, 2, 3, 4. Yeah, okay, cool. All right, let's begin where we left off then. So we were doing header guards, and we learned that we learned with if def, if n def, and end if. Right, let me just double check. Can I hear myself? Yeah, okay, cool. Let's continue then. So we learnt that in the last episode, or the last stream yesterday, we covered header guards. And we got to if not defined, then some unique name here, and then defined, and then the identifier there. So essentially, when this header is included in the preprocessor, the preprocessor will check whether some unique name here has been previously defined in the transition unit. If it's the first time we're including this header, it will not be defined, aka this here. So it would be something like this. So if n def some unique name, and then we're going to define some unique name, and then we would have the code here. And you can see here, if we do if ndef, or even if we do if def, we always need to have a end if. So we have if not defined of this, but then we have define some unique name. If the header is included again in the same file, some unique name will have already been defined from the first time the contents headers were included, and the contents of the header will be ignored thanks to if not defined. So all of your header files should have header guards on them. So I'll make a note of that if we haven't already. No, we haven't. Okay. Okay. We won't bother with the for example. We'll just do the for example ourselves. So, you got a header of square h, and if header of square h is not defined, if the header of square h is not defined, then we Sorry, I'm just looking at something's just come up. Okay. If the header of square h is not defined, we'll then define it, and then we have return type of integer, and we have get square slides and returning 4. Even if the standard library header get used, if you take a look here, look at the IO stream in Visual Studio Code, you'll see this, which is what we did last stream, but let's just double check. We go to IO stream. On your Windows, if you're using Windows, I think you use Control, but on a Mac, if you press Command and then you click IO stream, you get this, which is the library for IO stream. And you can see here we have if not defined, define, and then at the very end we have end if. Yeah. Okay, let's close that. Yeah, and the content goes here. Updating our previous example with header guards. So, and one thing I forgot to mention, I know I said I'd look into switching to Xcode. I had a look briefly at some of the some of the things we're going to be learning via C++, .com, and I think when I do my official projects, that's when I'll switch to Xcode. So when I do things like games or things like that, I will switch to Xcode, as I don't want to have to deal with setting up new projects, for worrying about the settings and all that kind of stuff. So for the time being, I'm going to stick with VS Code for now, and see how I get along. Just in case you were wondering about that, and we're still using VS Code. So we got if define square h, and then if in your wave h include square h. So we learnt last stream that if you have created a library yourself, you use where was it? Yes. So the paired to maximize the chance of missing includes, i.e. Directives, your includes should be linked or be ordered as the following. So paired header files, i.e. these will include in quotations. Then other header files from the same project will include quotations again and include. And then third parties like Boost, Tuple, HPP, and then standard libraries like IO stream, which would be include output stream. So you can see here we've done include square h, and we have the paired header file for yes. So what he means by that is, if you were to add square h and you wanted to include it as a directive, or via a directive, you would do square h under add h, i.e. here, this line 2, because the add h is a direct link to add CPP. Then you would do third party, and then you would do standard. Won't bother with that. And then in main, you would do this. So all after the preprocessor resolves all the include directives, the program looks like this. So in your main, square H included from main CPP. So this would be that if we didn't have multiple files, i.e. here, we wouldn't, it would all look like this. So square H is included from main CPP, if not defined, square H included from main CPP, define square H, and that gets all stored in here. And then you end square H. Then we have if end wave H, define wave H, if end square H, define square H, and then get square slides, and then end if square H, and we're doing square H here, and then end wave H here. We're ending wave H first, or last rather, because we defined it first. Just like how in the IO stream, we defined lib ccp IO stream, and then we ended it last. Yeah. That makes sense to me. First, the preprocessor evaluates if not defined. Where H has not been defined yet, so the code. So it's not been defined. So the code from if not defined is included. The code defines and has a definition in get square slides, i.e. here. Later, the next if not defined square H is evaluated. This time square H is defined because it got defined above. So the code of if not defined to the subsequent end if is excluded. In the next if not defined, so i.e. in this one, because we have already defined it in wave H, i.e. here, by including it, it means it's been defined. So the code from, that makes sense. Header guards prevent duplicate inclusions because the first time the guard is encountered, the macro doesn't get defined because we're using if not defined. So the guarded content is included. Past that point, the guard macro is defined, so any subsequent copies of the guarded content are excluded. Header guards do not prevent a header from being included once into different codes. Note that the goal of header guards is to prevent a code from being received more than one copy of a guarded header. By design, header guards do not prevent a given header from being included once into separate files, like we saw here. You got square H, and then you got square H again. So we got if not defined square H, define square H, and then we are defining square H as that. And then, so yes, we are defining square H as the return type of get square slides and returning, and then we're also getting square parameter. We got the forward declaration of get square parameter in the square header, like we have in add H, and then in square CCP, or in this case add CPP, we would include. So here we're including add H add h, but here we're including square h, which then gets everything within square h, which is all of this. And then we get the return type of get square parameter. So here we're doing the forward declaration as we learn, whereas here we're defining get square parameter. And in add h, we're doing the forward declaration, and in add CPP we're defining it. And as you can see in here, we then include add h there. We've included add h in our definition, but we've also included it in main CPP. So we got the return type of main, we got the output, a square has number of sides, and then we got a square of length 5 has a parameter length of 5. Note that square h is included in both main. This means the contents of square h will be included once square CPP, once into square PPP, once into main. Let's examine why this happens in more detail. Okay, so when square h is included, from square pp, from square ccp, square h is defined until the end of square pp. This define prevents square h from being included in square CPP for the second time, hence the guards. However, once it's finished, it's no longer considered defined, because when we reach the end of the squiggly brackets, it gets destroyed. Yes, that makes sense. This means that the preprocessor runs on main CPP. Square h is not initially defined in main CPP. The end result is that both square PP and main CPP get a copy of the definition of get square slides. This program will compile, but the linker will complain about the program having multiple definitions of get square slides. Okay, the best way to work around this issue is to simply put the function definition at the top of one of the CPP files, so that the header contains just the forward declaration. So the header should only include forward declarations, and that means the best way to work around this issue is to simply put the function definition, i.e. these, into one CPP file, so that the header contains just, okay, so when dealing with header guards, when dealing with headers and header guards, the best practice is to include the definitions in the CPP file, and then in the H header file only include obviously the header guard and the forward declaration. Now when the program is compiled, function, it's far and it's happy. Okay. Can't we just avoid definitions header files? Pragma once. I have no idea what pragma once means. Modern compilers support a simpler alternative form of header guards using pragma, preprocessor directive. Because remember, a preprocessor directive example is include. Is it include? Yeah. Is it include? So it would be like pragma once. Pragma once serves the same purpose as header guards, to avoid a header file from being included multiple times. With traditional header guards, the developer is responsible for guarding header guards by using, and I won't look at the screen for this, if not defined, and then the name, and then if not defined, and then the name, then you define, and then the name, then your forward declarations happen, and then after that you have the end file. Yeah, see, if not defined, define, and then you have the forward declarations, and then end if. Cool. With pragma once, we're using the compiler guard as a header. How exactly it does is specific details. But I know you can see the warning there, but the ability or the whole purpose of C++, and the whole reason why I'm learning it, is to have more control over my code and more control over my my projects. So I kind of have a intuition not to want to use pragma once, because it doesn't give me full control. So as you can see here, the pragma directive was designed for compiler implementers to use when they want. As such, with the exception of pragma once, do not expect a pragma to work on the compiler. Yeah. So instead of using, if not defined some unique name here, define some unique name here, then put your forward declarations here, and then end if. We can potentially use pragma pragma once, and I'll put that in bracket because I might think in the future that it's pragma, and then I'm continuing the sentence, but I'm not. But the pragma once does not provide full control, and it was designed, and then we'll just copy and paste that. Therefore, I would prefer to use, if not defined, some unique name here. Define some unique name here. Forward declarations, and then end if. Header guards are designed to ensure the contents of a given header file are not copied more than once into a single file. Duplicate declarations are fine, but even if your header file is composed of declarations, no definitions, it's still practice to include header guards. Note that the header guards do not prevent content from the header being copied once. That's true. The good thing is, because we only need to reference the contents of the given file. So we'll just copy that. Okay. Add header guards to this file. So we'll copy, I know it was the exact same, but we'll do the forward declaration of add int x, int y, and then now we'll add the header guards. So if not defined, some add name, then we define some add name, and then finally, to make our IDE happy, we do end if. And we don't need semicolons here. Correct? Add h. Okay. That's fine. We can do add h. Add h. Define add h. Alright, how to design your first programs. Now that you've learned some of the basics, let's see how to design it. You'll generally have a new kind of idea. It turns out the skills you need are the skills you already have, you got from everyday life. The most important thing to remember is to design your program before you start coding. Yes, because if you start coding and you have no actual design, it's a lot harder to continue and keep going and progress. Define your goal. This relates back to what does it relate back to? Somewhere here. Here, was it? There was like there was a good diagram about the 7 steps or something. Structure of your program? Or is that the one I literally just went on? No, it was. Anyway, there was a... This one? No. Anyway, there was a... See if I find it on this. I took a screenshot. Yeah, here we go. I'll just pop that up on the screen. It was that. Can you see that? Yeah. So we got define the problem to solve, design a solution, write the program, compile, link objects, test program, debug, and then 4 to 7 repeats and repeats and repeats itself. Okay. Where were we? How to design your first programs. Define your goal, aka define the problem to solve. For example, allow the user to organize a list of names and associated phone numbers, generate random dungeons, generate a list of stock recommendations, model how long it takes for the ball dropped off the tower to hit the ground. Although it seems obvious, it's highly important. Then define your requirements, design a solution. Oops. For example, phone numbers should be saved so they can be recalled later. The randomized dungeon should always contain a certain way of getting to the exit. Stock recommendations should leverage historical data. The user should be able to enter the height of the tower. We need a testable version within 7 days. And so on and so on. Define your targets and tools. Determine what OS the program we run on, determine the set of tools, and then continue on there. Break hard problems down into easy problems, which is... Oh no, actually, I take that back. It's not the same as this. This is actually this is writing the program, whereas this is coming up with an idea for how the program is going to be run. And as always, yes, so here he's talking about backing up your files. Now this can be done either by putting them on a flash drive. The best backup is to put a copy code onto your machine that exists in a different physical location. There are lots of easy ways to do this. Zip it up and email to yourself. Put it in a Dropbox. Use a file transfer protocol to upload it to a server you control. Or use a version of code system redesigning to another machine, i.e. GitHub. So GitHub is a very useful tool where you can create an account quite simply, and then you can upload from VSCode or Xcode or whatever compiler you use, and then you have another version of it. So you can work on your local machine, i.e. VSCode or Xcode or whatever you want, and then when you get to a certain point, your Git repository can then be uploaded, what is it, this one? Yeah, publish branch. And then you can upload it to GitHub. That way you have a version on your local machine, and if your local machine ever becomes corrupted, you have all the files and all the data you need there. You can also link VS Code with Xcode. So, for example, if you did all your work on Xcode and you set up the GitHub on the GitHub repository, the source control on your VS Code, you would then have it in essentially two places, and you could even make it even safer with a third by uploading it to GitHub if you wanted to. Now, you might have heard sometimes that code was found on GitHub. You can make your files private on GitHub, just as a heads up. There is a way to do that, and it is quite easy. But I won't be going into that today. So break hard problems down into easy problems. So cleaning the house. Cleaning the house is a big thing. You got to vacuum, clean bathroom, clean kitchen. Clean the house, make it more into substacks and more easy to do. Clean the house, vacuum the carpets, clean the bathroom, scrub the toilet, wash the sink. Kitchen, countertops, scrub the sink, take out the trash or the rubbish or whatever side of the Atlantic you reside on. Now we have a hierarchy, none of them hard. By completing each of them, we can complete the more overall difficult tasks. The other hierarchy is bottom up. As an example, many people go to work or school days on weekdays. So let's have a problem of go to work. If you were to ask what tasks you did in the morning, you would come up with these. Using up a bottom-up approach, you get out of bed, bedroom things, bathroom things, yeah. And if you want to take time to read this, we are on lesson 2.3. The sequence of events. For example, if we were doing the calculator, we would get the first number from the user, get an operator, get the second value, calculate the result. Implementation, outlining your main function. Now you're ready to start implementation. The above sequence can be used to outline your main program. I am not going to copy all of this into my notes. So what I'm going to do is, under here, I'm going to do designing the structure of a program, and then I'll copy some of it. So define your goal. And then what I'll do is I'll just copy the first. No, what I'll do actually is just revert back to lesson 2.13. And that way I have a much more detailed, and I'm not taking as much space because the file's starting to get big. Okay, implementation, outlining your main function. Now we're starting, we don't need to worry about the inputs and outputs for the time being. Do bedroom things, do bathroom things, do breakfast things, do transport things. Or in our case, a calculator, get user input, mathematical operation, second user input, calculate, print. Note that if you're using this outline method for constructing your programs, your functions won't compile because the definitions don't exist yet. Yeah, true. Commenting out the functions will commenting out the function calls is one way to do it. Alternatively, you can stub out. I believe you can also just use if 0, no? So let's just, if we got rid of this, and then we did int main, and then say we copied all of these, but what we did was uncommented them. I believe what you can also do is if you don't want to comment them and have to keep worrying about whether whether the whole section is commented. I keep doing that. Whether the whole section is commented, you can just do this, no? So if 0, and then we do, but if 0 needs to be that, and then we do end if. Yeah, that is also another way to comment out your code. You can do if 0, and then all of this is grayed out or blurred out, and therefore it won't run. So we'll return 0, and just to show you, we'll do for example, standard character output. We'll do hello world, something simple like that, with a line break, and then this should run, but it will only run for our hello world. Run and compile. There we go. And then if you wanted, if you then did these functions or defined these functions or these calls, you would then do if 1. But because we haven't defined, we then get errors. So I'll go back to 0. Yeah, hopefully that makes sense. It does to me. Implementation, implement each function, i.e. define it. And then you want to test each one. Fairly straightforward. Let's follow along actually, just for practice. So I'll get rid of this again, and then I'll include IO stream. You got an int of main. Why is my include? Okay. We got an IO stream. Okay, so we do the calculator version. Well, first of all, we'll define user input with int get user input, and then we'll have braces, then we'll have a character output of enter an integer. Then we will, as always, I'm trying not to look at the example, then we will have, I assume, we need to define and make it unassigned, so we'll do int input. I'll just bring that back there. We'll make it unassigned, Then we'll have a character input of input. Then we will assign, no, that should be the other way around. Then we will return input. I believe that's the correct way to do it. So that should be what we see here. And we do. Cool. We got the character output of enter integer telling the user what to do with the exertion operator. Then we make it we define input and make it uninitialized. Then we allow for user input, which then initialize and defines it. So then within our main, we can then get the first number. So we'll create an int of value, and we will assign it to our get user input. And then when we're calling a function, we need to remember to include the braces. And then we don't necessarily need to, but it's always good to return 0 in our main. Note we've included code here to test the return value. Debug code to ensure get user input is working. Okay. And our return is seeing there because I forgot to do a semicolon. So we'll debug the code here, and debugging the code is very useful because it helps you or allows you to go back to your code and see what you might have done wrong and where things are going wrong. So let's just test that. Let me clear my terminal. Enter an integer, 1. We can then, let me just think about this. What we'll do is we'll debug it even further. We'll do std character output, the user, why is that not, there we go, the user has entered, and then value with a line break. And then we should get enter an integer 1, and when I press enter, we should see the user has entered 1. Cool, nice. I'll just add a full stop there, which means we need to do a double quotes and n, and then we'll run it again, and we get the full stop there. Okay, nice. So we've got the user input, takes no arguments because we don't have any parameters. Yeah, remember, don't implement your entire program in one go. Work on steps. It's the little steps that end up to be something massive, as we discussed earlier. And then final testing. Once the program is finished or you're very happy with it, we need to test to see if it doesn't work, to see if it works. Word of advice: keep the program simple. I'm not going to read all of this because I'm fairly confident with programs and how to set them up. But if you're new to coding and you're new to C++, which I am, to be fair, but if you're new to writing programs in general, this is I would advise you to read this. So we're on lesson 2.13, on learncpp.com, and I would suggest to read this. Conclusion. Okay, many new programs. Okay, cool. Let's move on to the summary and the quiz. So I will just, how long is this? Oh no, okay. We'll do this, and then we'll take a 5-minute. I'll just go on a break. So a function, design your first program, function and functions, and chapter 2 summary. A function is a reusable sequence of statements designed to do a particular job. Functions you write are called user-defined functions. A function call, i.e. when we call a function, such as get user input, and we've called it in our main, tells the CPU to execute the function. And remember, within the function, we can have parameters. When defining the function in the braces, we call them parameters, but when we're calling the function and we put in the brackets, these are called arguments. The curly braces are called a function body, i.e. this. A function that returns a value, the return type of the function indicates what the function will return. So yes, so far we've done int, which means we must return, but we can also have void, which means it doesn't return anything, and as a result we don't need return input, and then we won't need that as well, but we'll go back to that. And then the return type in general, 0 tends to mean success. Dry programming is important, do not repeat yourself. Return functions with a return type of void do not return a value to the caller. A function that does not return a value is called a void function, or a non-returning function. Return statements. A return statement is not the last statement in a function. A function parameter, as we discussed, is what happens in the brackets. And an argument is when we call it and we need to put it in, if we need to put values in the brackets. Function parameters and variables that are defined within the function are called local variables. Here. A variable that exists, the time in which the variable exists is called the lifetime. Variables are created within the runtime. A variable scope determines where it can be seen and used. And it comes out of scope when the braces end. White space refers to character spacing. Forward declaration, as we did here, allows us to tell the compiler about the existence of this before actually defining the identifier. To write a forward declaration for a function, we use the function prototype. A definition would be this, and actually implements the functions and creates statements, variables, and things like that. A declaration, which is this, tells a compiler about the existence, like we just talked about here. Pure declarations are declarations that are not also definitions. Most non-trivial programs contain multiple files. Sorry, let me just check something. Yeah, okay, cool. When two identifiers are introduced, the same program, naming collision. The preprocessor is a processor that runs your code before it's compiled. Directives are special instructions to the preprocessor. Directives start with a symbol and end in a new line. A macro is a rule that defines how input texts are required. We got header files. When using the include directive, the include directive is replaced by the contents of the file, and we use the extension of H. Header guards prevent the content from being more than once, and the header guards is, if not defined, the name, define. Then we typically do forward declarations. We don't do definitions, and then we need to end it in end if. Cool. Quiz time. Okay. Be sure to use your editor's auto formatting feature to keep your format consistent and easy to read. Write a single file program named main.cpp. So what we'll do is we'll go to our main.cpp. I'll just clear the terminal. A function named readNumber should get and should be used to get and return the single integer from the user. A function named writeAnswer should be used to output the answer. The function should have a single parameter and have no return value. A main function should be the glue to put it together. So I assume we can get rid of this. Hang on. A function named readNumber should be used to get and return a single integer from the user. Does that mean we include what? No, I think this is separate to our example. So let's give that a go and see how we do. So we'll get rid of this. We'll get rid of the directive, and again type in include iostream. So we want a function that called readNumber that should be used to get and return a single integer from the user. So int readNumber. For now I won't do parameters, and it will be std character output, and then we'll have enter an integer. Then we will define we will create an uninitialized input, or let's do number rather than input. Then we will have the user actually enter the number. So we'll have std character input, and then that will be the number. Then we will want to return said number. So that's that. Then we want a function named writeAnswer should be used to output the answer. The function should take a single parameter and have no return value. So, no return value. So I assume then that means we just need a character output to print. So we'll do int write answer, and then single parameter. So we'll do int x, then we'll write the body. We'll do the character output of the user has entered, and then x, and then we'll have a full stop and then a line break, and then we do not need to return x. That should be all good. Then we need a main function to glue it all together. So we do the int main, and we need to write the answer, and we need to read the number and write the answer. Now because, and let me first of all, let's get the easy one out of the way. So we need to show the answer that the user has done in our main. So we need to use writeAnswer. From what I've remembered previously, when we had something similar, an example of something similar, we what did we do? We had a function that got the input from the user, and then we displayed the answer. I think it was a double or an add or something like that. And we used the one with a parameter because it wouldn't make sense to use read number here and then call writeAnswer. You need to write the answer and call you need to call writeAnswer, and then in the arguments you need to put in read number. This is because read number doesn't have a parameter and is only concerned with reading the number, whereas writing the answer has a single parameter. So I think the best way to do that is writeAnswer and then read number, and then semicolon, obviously. So I think, and then we have the main function, yeah. So I think we've covered everything because we've created the read number function, and it returns a single integer. We've created the writeAnswer and should output the answer, and should take a single parameter and have no return, which it doesn't. Then the main function is the glue that brings them together. So I think that's good. So let's have a test. Enter an integer. Let's do 10. User has entered 10. Cool. Nice. Although I don't know why we're getting doubles. There we go. What is wrong here? No, okay. So, because that's the one thing I must have missed. So there is no return value. So I'm going to make this void. and it seems we haven't had any complaints with this. So I'm going to close the terminal there. That must have been why we were getting the 2. So save. But then I'm still getting... But that is a non-void function. Maybe if I run it again. Yeah, I'm not getting the error anymore. So 1. Cool, 1. And you can see here the build finished successfully. Okay, cool. So the only thing missing was the int, was the return type, because if we did the return type of integer for the function, we would need to return something. So let's see if, let's first of all see the hint. You need to write a separate function. Yeah. You need to call read number. You will need to call read number twice. Have I misread the whole thing? 2 separate integers. My bad. Yes, you would need to call read number twice. So, yeah, because we're adding them together, aren't we? Okay. So in that case, we'll do int x is right answer read number. Should take a single parameter. This function should take a single parameter and have no return value. So we got the single parameter. We then need to make sure that it adds. I would have thought, what about if you did int x, int y, and then we have the sum. It helps if you actually read what you're supposed to do. The sum of these 2 digits is x. And then you need to do int sum x plus y, right? And then, no, read number, and then you can get rid of this, and then in here you can do x plus y. Correct? Or, to make it simpler, you would get rid of integer x and integer y and just do read number plus read number. Let's have a look at that. Enter an integer 1, enter an integer 1. The sum of these 2 digits is cool. So what if we actually did, we got rid of that and we simply called read number plus read number? Would that work? I mean, assume it would do, because we're not including a comma and we're not including another argument. So surely it would, wouldn't it? So let's try that. So it's compiled. Yeah, 2. Okay, it definitely helps if you actually read them together, because I was reading it as 1, but obviously that makes a lot more sense. Okay, hopefully that's on the right line. You could probably make that code better. Let's have a look. Enter a number to add. The answer is, yeah. So the original one we did here of this was fine. But you could also do like we did, plus read number, although thinking about it, it probably is better to actually assign and initialize it in the first place before calling it. So I think I prefer actually the x plus y. Okay, cool. Using the plus operator, yeah. Modify the program you wrote in exercise 1 so that read number and write answer live in a separate file called IOCPP. Use a forward declaration to access the main. If you're having problems, make sure the IOCPP is properly added. Okay, cool. So what we'll do is, remember last time we had compile issues, so we'll just add IOCPP, which again is why I think when I set up my projects, I'm going to be using Xcode, because none of this is needed for Xcode. I had a look and it doesn't seem like it's needed. So we'll create a new file. We'll do IOCPP. Then we want to define the variables, set up the definitions, but because we're setting up the definitions, we need an IO stream. So include IO stream, and then what I'm going to do is, instead of copying and pasting it, I'm going to write them again. So we have a read number, I just want to hide that. We have a read number, and we have a write number. Now our int read number doesn't have a parameter, and we have print out enter an integer. Then we define the integer, or make it uninitialized, input. Then we ask the user to enter the input. Then we return said input, and I need to make sure that it's character in. So that's the definition, which is all good. Now we need to add the write number, which is going to be void because we're not returning anything. And then we have int x, and then the body will return or output the sum of these 2 digits is x. So that's all good. We don't need to include any headers yet, because Because I assume, is that what we're doing in question 3? Yeah, we are. So for now we won't do that. So what we'll then do is in our main, we can then comment all this out. But before we do, we can comment out because the names might have changed. So now what we do is we do int int read number, and then we don't need to pass in any parameters, and then we do int right number, sorry, not right answer, and then we need to pass in int x as a variable. So you can see maybe I should have copied and pasted it, but I prefer to write out the code, and then that's just for practice sake. So right number, this needs to become right number, and then that should hopefully compile into an integer 1, 1, 2. Cool. Yeah, that's what we had. Again, I'm forgetting that integer, the void return type. That was the only thing. 1, 1, 2. Cool. These are forward declarations as per IOCPP. Nice. Modify the program you are in 2 so that it uses the header name IOH to access the function declarations. So what we'll essentially be doing is we'll be removing these forward declarations. Declaration, it doesn't matter, it's commented out, it doesn't need to be spelled exactly. So what we'll do is we'll do a new file, we'll do IOH, and then we will practice good code, and we will do if not defined IO header, then we will define IO header, then to make our IDE happy and C++ happy, we'll do end if, and that will get rid of the red there. Now we need to call the forward declarations, declarations, and to make sure I get the names right, so in main we'll do read number, int read number, and then void right number with the integer of x as the argument, and that should still run, hopefully. We'll clear the terminal, we will get rid of these, we then, I almost forgot, we then need to call the IO header, and because we created ourselves, we put it first. So we include IOH, and that then gives us access to read number and write number. Cool. That should then run. We then get integer, because it's not an integer. We then run it properly. 1, 1, the sum of 1 and 1 is 2. Nice. Show solution. Yeah. If defined. Okay, so instead of header, they did H. Maybe that's a better way of doing it. So we got our IOH here, and then we got our IOCPP, and then in our main we call the IOH One thing I missed here was I need to include the IOH header. Okay, so you include the IOH header in CPP and main CPP. Okay. Yeah, whilst it doesn't require, it's best practice. Yeah. Okay, that is the end of chapter 2. Now we will move on to debugging, I believe. Yeah, debugging programs. So what I'll do is I'll just start up that. I will then save to my, so day 5, part 1. And what did we cover? We covered, and notes would probably be best. We covered header guards, we covered also programming structure with this, and yeah, that was it, wasn't it? Yeah, just continue with header guards. It'd be helpful if I spelled guards correctly. Why not to use pragma once, and then yeah, designing the program, and then we just did the quiz. So tutto bene, and then today's date is the 2nd of August, and then commit. Okay, cool. Now we're on to debugging, but I'll be back in just a second. Be right back. Okay, so how are we doing? Should be still alive. Yeah, sounds all good. All right. So, let's continue then. So, debugging. Yes, debugging. Syntax and semantic errors. Syntax errors. Programming can be challenging. A syntax error occurs when you write a statement that is not valid according to the grammar. For example, this. I think this section should be, well, he says, should be fairly straightforward because it's more about how you're trying to find errors in the code rather than actually writing the code. So actually, let me just chapter 7. Debugging. And then scroll down here. 7, debugging. And then, okay. So a syntax error, like for example, you probably came across this when you were at school. Whoops. Syntax error. You probably came across this when you were at school. Like if you entered the wrong thing into your calculator, you got a syntax error. So for example, in here, we have a main function. But it's missing the closing brace. And we can't start an integer, so that'd be another syntax. And there's no semicolon here. And there's a semicolon here as well. And the operator doesn't exist. Okay. Semantic error. Semantic error. A semantic error is an error in meaning. These occur when a statement is syntactically valid, but either violates one rule of the language or does not do what the programmer intended. Some kind of semantic error can be caught by the compiler. Common examples include undeclared variables, type mismatches, when the object with the wrong type is used somewhere. So you got semantic error. I'm copying and pasting these because they make sense to me. If you want to write it out yourself to make sure that it makes sense to you, feel free to do so. So 5 has not been declared, and you cannot return hello because our return is an integer. Okay. Yes, so Okay. Okay, that made all those made sense. So the debugging process. Let's just copy and paste that. Let's say you've written a program, it's not working correctly, the code compiles fine, but when you run it, you get the incorrect result. For example, if you got 1 plus 1 and you get the value of 3. But how do you find it? A general approach to debugging is considered 6 steps. The debugging process generally involves 6 steps. Yeah, I've done a lot of debugging. So debugging is a thing you do quite a lot. But I find that sorry, hang on. Let me just. I find that you don't actually define, or it's not often that you define what the process is. You get so used to it that it just becomes you don't think of it. It's like when you drive a car, you've done it so much you don't actually think, right, foot on the clutch, select the gear, put it in first, then I find the binding point, then I go, and then I do the exact same when I want to change gear. So find the root of the problem. Yeah, usually you'll get the line of the problem in your terminal. Ensure you understand why the issue is occurring. Determine how you'll fix it. Repair the issue causing the problem. Retest it. Retest to ensure no new problems have emerged. That's another thing. When you're debugging, sometimes it can you debug one thing and you fix it, and then another problem occurs. Probably because what's happened is the line of your compiler, your IDE has gone through the lines of code. You stop at this one, and then you realize, oh, I have problems here. So it doesn't actually create more problems. It just shows the existing problems. Those all made sense to me. 1, ensure. 2, determine. 3, repair. 4, retest. 5, and retest again to see any other problems. Okay. You put your cup Yeah, I think I can skip on this one. So, repair the issue. Okay. Sorry about that. I was just focused on something else. So here, this function is supposed to form add, but we're returning the wrong operator. So then the function says add, or the function says add, but we actually are in our return type. You can see there that we actually are deducting or subtracting. So in reality, this should be made to subtract, and this should be changed to subtract, and then 5, and then here we would put minus, and then it would produce 2. This code is nice in one regard, but the bug is very apparent. Yes. Line 10. Line 10. This starts giving us the point. So the root of the cause is on line 10, as we're passing in the arguments. Since inputs to the functions add are correct, but the option wasn't, it's very apparent that the function add must be producing the wrong value. Yes. The only statement in the function add is the return statement, which is this. Yes. Now we found the problem. Understand the problem, and then we need to fix it. So we need to change the minus here to an add. Yeah, cool. That's fairly straightforward. Strategy for debugging. When debugging, in most cases, the vast majority of your time will be spent trying to find where the error actually is. Once the issue is found, the remaining steps are often trivial in comparison. In this lesson, we'll start exploring how to find errors. So we have a return, we have a function with the return type we have a function with a return type of integer, and it calls get names, sort names, print names, and returns 0. If you expected this program to print names in alphabetical order, but it printed in the opposite order instead, the program is probably in sort names, because we've got the names, but the sort names is not in alphabetical. It's from Z to A rather than A to Z. In cases where you can narrow down the problem down to specific, you may be able to spot the issue just by looking at your code. However, as they get more complex, so does finding the issue. First, there's a lot more code to look at. Looking at every line of code in the program is not can take a long time and can be boring. Second, the code itself tends to be complex, with more places being wrong. Third, the code's behavior may not have clue. Are we still? Yeah, our volume's still good. Yeah, okay, sorry about that. Third, the code's behavior may not give any clue as to what's wrong. If you wrote a program to output stock recommendations, and it's outputting nothing, you probably won't have much lead on where to start looking. Finally, bugs can be caused by making bad assumptions. It's almost impossible to spot one because you are likely to make the bad assumption in inspecting the code. Fair enough. finding the problem by running the program. Fortunately, if we can't find it via inspection, there's another way we can do it. Figure out how to reproduce the problem, run the code, repeat it until the error is gone. Reproducing the problem, okay. Homing in on the issue. Once we are able to reproduce the problem, the next step is to figure out the issue. But how do we find it? High and low gain. Me 5 too low, 8 too high, 6 too low, 7 correct. In the above game, you don't have to guess every number. We can see, however, we do not know. Yeah, okay. Often whatever is the cause of the problem. For example, if the program isn't writing data, I am skipping or skim reading this because I have had a lot of experience with debugging when writing apps and writing websites. But again, if you are new to programming it, I would highly recommend reading this because this is actually a good guide as to how to debug, especially for beginners. And I certainly didn't have this when I was beginning, so I'd recommend it if you're brand new. So lesson 3.3 and lesson 3 onwards. I'm more looking for examples, really, just to get even more practice. Okay, there we go. That's probably more like it. Debugging tactics. Debugging tactics, i.e. how to debug or how to set up things or set up your code and file to actually debug properly and show the errors correctly. So commenting your code, basically the commenting of your code can allow you to commenting your code basically allows you to write things that will not be run when or compile when the application is run, and you can therefore use it to say this function does this and that function does that. And then, as well as making comments, as we learned previously, we can actually comment out lines of code so it won't run, which is another way of finding the specific error, as per here. That makes sense. The program goes away. When you find the problem and you fix it, don't forget to actually uncomment your uncommented your commented call function or commented code or commented statements. After making many debugging changes, it's very easy to miss one and do. Yeah. Yes. An alternative approach to repeatedly adding or removing. Okay. I did not know that. We can use third-party libraries such as macro dgb, dbg, to prevent having to comment and uncomment our code. Validating your code flow. When printing information from the debug for debugging purposes, use std sir, so character error, I assume, instead of character out. One reason for this is that character out may be buffered, as we learned earlier, which means that time may pass. If you output using character out, the program crashes immediately. Okay. So it's like with end line and new line. Okay. That's one thing I didn't know, so I'll make a note of that. Okay. So let's give that a go, actually. That could be pretty helpful, to be honest. So let's have a look. So we'll get rid of all of this. We'll get the preprocessor, IO stream, return type for main of integer, and then before that though, we want integer, or we want a function called get value with the return type of integer, and then std, but we want that get value called, and then a line break, and then return 4, and then std error, character error, and then, so like with character output, character error uses exertion, extraction operator. Like character output, character error uses extraction error. Main called with a new line, and then get value, or standard character output get value, because our get value only returns a value, not actual output. Get value, cool, and then a line break here, and then we return 0. Let's see what happens with that. Yeah, main called, get value called, and it basically goes line by line. Cool. When adding debug statements, it can be useful not to indent them. This makes it easier to remove them in the file later. Okay. Let me just copy this and close some of the files. And we'll just scroll down here. We can use to help with debugging, such as the example below. Cool. Okay, even though I was following the example, I didn't exactly follow the example because our get value in the example didn't have the parentheses, i.e. when it was called. But then even if you did that, your IDE, I assume, would complain? No. Instead of getting here, you would get here. Okay. And you would also get an error here, and then the error as well in your terminal. Okay. Right. That makes sense though. Printing values. With some type of bugs, the programming may be calculating or passing the wrong value. We can also output the value variables, including parameters or expressions, to ensure they're correct. Consider the following program that is supposed to add 2 numbers but doesn't work correctly. So we have an integer of add, we have a function of add that returns x and y, and then we have a function of void that has a parameter of z. The answer is z. We then have a get user input with a standard character out, uninitialized character in, and then a return type. Then in our main we have x of getting user input, we have y of getting a user input, and then we have z calling add of x, add 5, i.e. x plus y. Then we have print of z, print result of z, but we haven't defined z. So surely this is just going to produce whatever the user has entered plus 5, and will not print result, because whilst we have z here, we're not actually, oh no, sorry, it will print result because we've defined z here, and initialized it. So this will produce, if the user entered 1, this will produce 6, I believe. Yeah. Although it's 4 plus 3. No, I see the error, because we have our get user input, then we're creating z, and we're printing z, which is related to the first integer. So if you did 1, you would get 6, but the user might have done 1 plus 1 expecting 2, but because we're printing the result of z, we actually get 1 plus 5 is 6. And because we're not doing the character output of add, standard character output of add, it won't actually add 1 and 1, it will add 1 and 5. So 4, so in this instance, if you entered 4, it would be 4 plus 5, which would be 9. Yeah, that does make sense. Yeah, variable z isn't. But you still get the answer of 9. Variable y had 3. Yeah. So to fix that, you would do integer z add, you would just get rid of 5, wouldn't you? And put in x and y. Oh no, let me know if I'm saying that right. One more example. So we have also doesn't work. So we have the same function, we have the same print. Here we have minus minus. So and then in our main, they fixed the x and y, but our x is now negative negative, which in maths typically means a negative negative becomes a positive. However, I have a feeling that it will just cause an error, or will it not actually be? So 4, they enter 4, but we have minus minus. 4 minus minus 4 plus 3. So clearly something's gone wrong here. I actually want to do that myself, just to check what it is. So include IO stream. Then we want to int add int x and int y. Then we will return x plus y with a semicolon. Then we will do void print result, and then that will give us, we'll then have a parameter of int z, and we'll have a character output of the answer is z, and then the line break here. And then we'll have the input get user input, get user input, and then the body will have std character output, enter a number, and then we'll create an uninitialized integer of x, and then we'll create a standard character input of x. Then, as per the example, we will return minus minus x, which is what's causing the issue here. So then return spelled correctly. Oh, no, that's why, because I didn't have a semicolon. Then in our main, we'll have the return type of integer, and then we'll have the body of int x get user input, and then int y of, again, calling get user input. And then per the example, we'll have int x, int z, integer z, and then we'll have add, and then we'll call the parameters here, x and y, and then we will, as always, return 0. Okay, so then we will then need to start debugging, and we'll debug it with standard character error. Std character error add called, was it? Add called add called x. So why was then, so the issue is clearly here, but we need to debug it somehow. So we're using character error. So add call character error, and then we'll do another double brackets x equals double quotations exertion operator, and then end that in braces, quotations again. Then we'll do a space. Then we'll do y equals and then that there, and then another exertion bracket, and then y, and then another exertion. This is getting a bit complex syntax, and then outside of that bracket we will then have n. Is that correct? Let's have a look. So add called x equals x and y. Okay, that makes a lot more sense now that I've considered it. So x x is x and y is y. That makes sense. Then we do the print result, std character error, print result call, and then we'll do z equals, and then again within the double quotations we'll do z is that, and then we'll do a new line. This is actually quite complex in terms of the syntax, and I need to get used to this to be able to get better regarding that. So then in our get user input call, we'll do the same thing, and we'll do std character error, and then get user input function called, and then we'll do brackets again. Actually no, we won't. We'll just do a new line because we're not actually entering a number here, and we always need to include syntax. We always need to include semicolons. We still have the minus x. So in our main, we're calling the main character error main called with a new line, and then get user input std character error std character error main x equals main x equals, is that the correct way to do it? And then a line break here, and then because we're doing that because we need to show in main what x and y is. So std character error main y equals y. So character error for debugging works the same as our character output, in the sense that we can have things outside of the initial brackets and the initial quotations. So then a new line here, and then std character error main z equals z, because now we're adding them together, and then we'll do the and the. Cool. So now when we go back and forth, when we go and run the code, we should be able to debug it. So let's first of all clear the terminal. And then run it. Okay. So I've done something wrong here. Error, linker failed to connect. Is that because, no. Include IO stream. What have I done wrong here? One duplicate symbol. We got a minus there. That's probably what he's talking about. What am I doing wrong here? I think it might be one of these, so what I'll do is I'll just copy and paste. And I think that might be what's wrong. I'll copy and paste these. But I think it could also be the minus. You see that changed slightly. Oh, it's only because of the space. So that's not the actual. I think it could just be complaining because we got the minus here, but that's per the example. Okay. What if we got rid of the minus? One duplicate. Wait, why is my main gone? Is that the is that what happened? Show errors. What is happening here? I'm copying it exactly how it is. What about if we copied the whole thing and tried it again? Have I just got an issue with my terminal? Is that it? Add int. No, so is it because we're not calling the I know exactly what's wrong here. It's because we've still got this. So we'll get rid of the add CPP and we'll get rid of that because in our main, okay, we have two adds and that should run, he says. Cool, nice, it does. Okay, so that was just a me not realizing that I should have just gotten rid of, or deleted rather, the the previous adds, so it works. So we got main called 1, main x equals 1, y is it because I've entered 1 or 3, 4? So it's minusing. So we've entered number 3, but we've got minus minus becoming 2, and then we've got 3, and then we're returning minus minus 3, which is 2. So then we have, so at least we know there that our x and y, our add being called, is correct. So we know that it's adding correctly, but it's not storing the numbers correctly. Okay. The user entering 4, but mains x is getting the value of 3. Something must be going wrong where the user inputs. Let's make sure the program is getting the correct value. Yes, because that's the important part here. The program needs to get the correct value, so we can actually calculate or show the user the correct. So that means that the issue would be here. Yes. So we do std character error, extraction model, extraction operators, get user input x equals x, and then a new line break. So let's give that a go. And let me just clear first. Yeah, much better. So 1, user input was 1, but main x is 0. 1, user input of x is 1. Okay. Clear. Let's run that again, but with actual numbers. Like, let's do 10 and 9. So you've got 10 and then 9. So the answer is 17. But our main is producing, the answer should be 19. But our main is deducting it. With this additional line of debugging, we can see that the user input received correctly, and somehow the mains variable is getting the wrong value. So our input, our get user input, is receiving the correct, but we're obviously returning something that's not correct. The problem must lie between our get user input, i.e. this, and our main, i.e. this. The only culprit left is the return value of the function. Let's look more closely. That's odd. XXX, what's that before x? We haven't covered it in tutorial, so don't worry about it. So we know that it's at fault. So then we just need to simply remove those two x's, because for example, say we had fat fingers and we just accidentally pressed minus minus twice. So now when we run the code, clear the terminal, and then we shall run it. And we'll see what happens there. Cool. 1, 1. The answer is 2. Cool, correct. How are we looking on my sound? Yeah, we should be all good. Right, let me just turn that down. Okay. Right, next up is cool. Yeah, it can add clutter to your code, can't it? But at least we've made a note. Why was that taking so long, actually? That's one thing I just want to check. Okay, so it was just a one-time thing. Maybe it's because I had deleted by accident my my main. More debugging tactics. Okay, cool. Let's move on. How many are we going to finish debugging today? Let's have a look. Possibly. What's the time now? 12:30. We'll probably go for another hour, and as a result, what I think I'll do is I'll take a little break here, and I'll be back in a minute. Okay. Oops. Are you still good? Yeah. Um, we still good? We still good? We still good? Hang on. Hello? 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 No. Hello? 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 Okay. Can you hear me? Um, can you still hear me? Yes. I'm just trying to figure out my mic at the moment. What about if I did? Hello? No. Hello? Alright, that seems to be a bit better because my typing of the keyboard is a bit loud. So what about if we remove that? Does that make a big difference? Yeah, that makes a big difference. So what I'll do is I'll add that back. Yeah, that's much better. My keyboard is now not as loud. So hang on, let me just, and then if I get rid of the noise. Yeah, okay. So we'll add that back. Yeah, okay, cool. I think we're all good now. How about my audio? All good? All good? All good? Okay, cool. Um, yeah, let's continue. All right, so we're on for another hour probably. Let me just, I want to see how my keyboard sounds when I'm typing. So just typing on my keyboard, and then how is it on the YouTube? Okay, I think that's a lot better. Yeah. So that was quite loud. And then now compared to this. Yeah, okay. I think I've sorted the noise issue. All right, let's continue. Cool. Debugging. Um, okay. Apologies for that. Where were we? Be right back. Okay, cool. Let's continue. So, debugging statements in your clutter your code. Debugging statements. Clutter the outside of your program. Require modification. Yes, and debug statements must be removed. Yes. We can mitigate these issues in this lesson. We'll explore techniques to do so. Conditionalizing your debugging code. Consider the following program that contains some debug statements. Okay, good. I think I've sorted that issue. Apologies for that if it was too loud. I didn't realize at the time. Okay, let's continue. Right. How are we looking on the sound actually? Let me just check my mic. Testing 1 2 1 2. And now testing keyboard types. Yeah, okay. We all Gucci. Okay. Consider the following program. Um, Considering the following program that contains some debug statements. So standard character error, um, get user input called. Enter a number, integer x, standard character input x. When you've done the debugging statement, you'll need to remove them or comment them out. Then, if you want them later again, you'll have to add them back and uncomment them. Yes, this is true. Um, One way to make it easier to enable debugging throughout the program is to make your debugging statements conditional using preprocessor directives. So include define enable bug, comment out this disabled, comment out to disable debugging. So if def enable bug, standard character error. So what it's basically saying is that if the character, if enable debug is defined, which is what we've done here, we will run this code. That's not a bad way to do it. And again, if def enable debugging, if it's defined, then we run this debugging line code here. Now we can use debugging simply by commenting and uncommenting define enable bug. This allows us to reuse previously added debug statements. True. Using a logger. An alternative approach to conditionalized debugging via the preprocessor is to send your debugging information to a log. A log is a sequential record of events that have happened, usually time-stamped. This is called logging. Typically, logs are written to a file on a disk called a log file, so they can be reviewed later. Most applications help diagnose the issue later. Hello, hello. Okay. Using a logger. They have a few advantages. You can avoid the clutter of this. C++ contains an output of std log, clog. However, by default, standard log, same as For illustrative purposes, we'll show the outputting to a logger looks like a plog logger. Plog is implemented as a set header file, so it's easy to include anywhere. Okay. Step 1, include the logger header, and then there. Plog is defined in the plog library. However, here's the output from the above logger. Main called, get user called. How you include, initialize, and use a logger depends on the logger you select. We won't use plog, so there's no worry to learn about. Okay. Using the integrated debugging stepping. Okay, what are we on the time? 1:45. We'll probably go for another 45 minutes, I reckon, or maybe half an hour. We'll see how we are at. So debugging stepping. Let's keep that. When you run a program, execution begins at the top of your main function and ends and runs until the program ends. Behind the techniques we've shown so far, that once you run the code, it will run compile. Okay. Fortunately, most modern IDEs come with an integrated tool called a debugger that is designed to do this, which I believe is this right here. Run debug C file. A debugger is a computer program that allows the programmer to control how the program executes and examine the program state while the program is running. However, the program can use the debugger to execute a program line by line, examining variables along the way. Okay. The power behind it is twofold. The ability to precisely control execution and ability to view the program state. Initially debuggers, later debuggers, these days, as per I just showed you there, we already have a debugger that we can run. Nearly all modern debuggers in Okay, this is debugging the code. So this is code block. For VS Code, to set up debugging, press Ctrl+Shift+P. And then add debug configuration. Launch JSON. No, so we don't already have that. So Ctrl+Shift+P, add debug configuration. followed by G++. Okay. And then change stop at entry from to true. Then open the main CPP and start debugging. Then open the main and start debugging by pressing F5 or Control-Shift-P. Debug. Start debugging and stop on entry. F11 on your Mac. Shift F11? No. Control-Shift-P, debug. Start debugging. Developer access tools, so I need to type in my password. So that has done that. By the debug menu, step into. Okay, so to run debugging, what about if we just did debug file? Control-Shift-P. Let's actually just remove the, let's remove all of this for now, and let's include, we'll just copy what he's done here. IO stream, IO stream void print value int value, and then we'll do std character output value then a new line break, sorry. Then in our main, we will print value as 5. Print value 5. Okay. So run. For VS Code users, step into command can be accessed by run. Can be accessed by run and then step into. But where is the step into? But where is step into? That's the only thing. Unless I'm missing something here. What about if we change this to debug? And then we start debugging. And then we see the step into there. However, so we've done that correctly. So step into is done here. Okay, so that gives us the value of 5. And then it gives us all of this information. And then we step into the next line of code. So that allows us to do line by line. And then it finishes when we get there. Oh, okay. So we got step into. We got step into. We can end the debugger there. Step into commands the next execute the next statement in the normal execution path. Yes, as we just saw. And then pauses execution of the program so we can examine the program's state using the debugger, i.e. this debugger here. If the statement being, I just want to get rid of that. If the statement being executed contains a function call, if the statement being step into causes the program to jump to the top of the function being called where it will be paused. So that means we, when we start the program, we go to print value, but then we actually jump to here. Is that correct? So we're in main, we're about to print the value, then we step into the print value. Okay, that makes sense. And then we step into and finish. Now we step into and then we end the function and then we end main because main calls print value and then we go into print value, we go here and then we want to end here. Um, yes. So that makes sense. Where was I? First locate um, and execute the step into the debug command. A visual VS Code. The step into command can be accessed via run step into. Ah, here. But mine isn't available. Is it because I need to use run? No. Add configuration. Nope. Ignore that. Yeah, okay, so now I can. So I need to actually run the program and then I can step into. Okay, that makes a lot more sense. Your program isn't running and will execute the first debugger. You'll see a few commands. The program will recompile when needed. Yes, our VS Code has a call stack here, and a what doesn't have a watch. Though. Yes, it does have a watch. My bad. We'll cover what these mean later, but for now you can ignore. Because we did step into, you should see some kind of marker appear, as per here. In Visual Studio, they're yellow, yes, but if you're using a different ID, they may appear differently. Makes sense. As per these illustrations and as per our or your or mine ID VS Code. The arrow mark indicates that the line being pointed to will be executed next. In this case, the debugger is telling us that the next line to be executed will be line 9. Okay. The next line will be line 10. The next line will be line 4. Step into. Yeah. Okay. To step into again. It seems that this terminal, i.e., this ID of VS Code, seems to skip over that slightly. So basically, it just steps into the next line of code. The version operator use okay. In the prior lesson, we mentioned that SCD is buffered. Yes. Um, to ensure all the output. If you don't want to continue, choose step into. Yes, as we see here. So we run and debug. We then step into there. We then step there. We then step there. Okay, that makes sense. And then we can finish debugging. Choose step into 3 more times, and at this point, yes, we'll finish. Okay. So, and you've watched it on every line of code. So step into essentially runs like a line of your lines of code would, i.e., you have your code running line by line. Okay. Future lessons will explore other debugger commands, some of which may not be available unless the debugger is running. If the desired debugging command is not available, step into your code to start debugging and try again. So then we have step over. So the step over command executes the next statement in the normal execution. However, whereas step into will enter the function to execute line by line, step over will execute the entire function without stopping and return control to you after the function has run. So let's give that a go. We will debug, run the debugger, run the debugger, and we'll do step over. Yeah, and as we saw there, when we run it, we first of all start in the main. We then will step over this function, and then we come to the end of the main. So essentially we've stepped over this, which means we've stepped over this definition here and all these statements here. Cool. Step out, unlike the other two, step out does not just execute line by line of code. Instead, it executes all remaining code in the function currently being executed. This returns control. So I assume he means let's just not assume what he means. Let's just give it a go. So step out. That will just end it. And it will not debug because you're stepping out of main. A step too far. When stepping through a program, you can normally only step forward. It's very easy to accidentally overstep in the place you want. Step back, which no, it is not restart. Enterprise Edition. I personally don't have Enterprise Edition, so I can't use that. We'll just end the debugger there. the goal of a step back is to rewind the last step so you can return to apologies. No, I want to go back on that. I want to go back on that. Yeah, implementing a step back requires a great deal of sophistication. Okay, cool. Running and breakpoints. How long do we have, or how many lessons do we have on debugging? Okay, we have quite a lot, so, and the time is 10 past 1. I think this will be a good time to end it, personally. Yeah, I think we might end it here. So part 2 will be, so we'll need to save it in our running and debugging. Well, how long is this? It's quite long. Okay, we'll end here. So what we'll do is, as always, we'll make a comment left off at lesson 3.7 using an integrated debugger, running and break points. So then in our Git repository, we'll just save what we did today. So day 5, part 2. Started debugging, covered syntax errors, covered semantic errors, covered the 6 steps of debugging, and set up the launch JSON for debugging for stop at entry, and setting that to true from false. And then we also, before that, practiced some more on headers and pre-processor directives. Okay. And then it is the 2nd of August 2026. Let's save that. Let's clear that. We'll only have those 2 files open. Do that. Clear the terminal. And yeah, hopefully the keyboard issue is fixed now and it's not as loud. Let me just type, and I'll try and hear in the video how loud it is. Yeah, that's much better. So going forward, the audio should be a lot better in terms of the keyboard. Okay. Uh, if you follow along, nice, well done. Hopefully you're getting better at C++ like I am. This was more about finishing functions and finishing or starting on debugging. Next stream, we'll probably do debugging, and then we will learn about data types. Yeah, so like void, signed integers, etc., etc. Cool. Um, we left off at lesson 3.7. Tell me anything you liked. Tell me anything you didn't like in the comments. Please like, comment, subscribe, all that good stuff, and I'll see you in the next one. Bye.